Okay, good morning folks. This is Mike coming at you with another video on Intro to Algebra. In the previous video, we talked about how we can use the additive and the multiplicative properties of equality to help us solve linear equations in one variable. In this video, we're going to continue working with linear equations in one variable, excuse me, but we are going to hit some word problems and some applications of linear equations. I know that when perhaps some of us hear that famous two-word phrase "word problems," that makes you shudder with fear. I know word problems are not the easiest for all of us, but they are very important to know how to work with and to know how to solve, because there are so many real-world uses for math. And not even for very complicated uses of math, and being able to take words and translate them into math and mathematical expressions and or equations is a very important and key skill. Now, when you're solving a word problem, there's not really one specific concrete method that you can use, or one concrete method which I can tell you that this is how you should do any problem like this, but there is sort of a recommended general set of steps or options that you have. So here's that sort of recommended and typically used process. First thing that you want to do, read the problem carefully and underline any key pieces of info that you have in your problem. What are key pieces of information typically going to be? Anywhere you see numbers, typically those numbers are going to be used in the solution to the problem some way, somehow. So identify and underline those key pieces of information that you need to solve the problem. Next up, draw a picture, draw a table, something to help you get a better visual of the problem. And based on the problem, you may not really have to do this, or it may not really help you to do this. But if you can, and if you think it's going to help you, draw a picture, a diagram, a table, something to help you get a better visual as to what's happening. And then label the picture or diagram or table. Fill things in, get information written down. And how do you do that? 3, you're going to assign a variable to stand for the unknown value or an unknown value. And for one fairly common type of problem that we see here, it's pretty common to see a problem where we have two quantities, and one quantity is specifically related to the other. Like, say, one quantity is 50 more than the other, or 5 less than 2 times the other, or something like that. So when we have this case, when we have two quantities that are involved, and we know that one quantity is greater than or less than or just related to the other quantity in somehow or in some fashion, when we assign the variable to be the first thing. Assign the variable to be the quantity that the other quantity is related to by the known ways. Greater than, less than by some number, or multiplied by something. That's typically a good way to solve those kinds of problems. Once you've done that, write an equation using the variable expression or expressions, and then solve your linear equation in one variable. And when you get your answer, think, is the answer reasonable for the context of the problem that you're in? As a case in point, If your problem is, say, asking what is the distance or the length for something, if you get an answer that's negative, then that answer just doesn't make sense because distances and lengths are quantities that are positive or equal to 0. So if you're getting a negative answer for that, then that doesn't make sense. If it's time and you're getting an answer that is less than 0, then that doesn't make sense. Time has to be, again, a positive number or a number that is equal to 0. And then once you've come up with your solution and your solution is reasonable, check it. Substitute that value back into the problem that you set up and just verify that it does satisfy the problem that was given. So let's do some samples here. So first one, the nations of France and Norway are projected to win 186 medals in the 2022 Winter Olympics, with Norway winning 78 more medals than France. How many medals are each country projected to win? So this is one of those kinds of problems where we said that we have two quantities and one is related to the other by adding or subtracting or something like that. This is what we highlighted here in this point. But again, let's go through our whole process here. First thing we do, read the problem carefully and then underline the key pieces of information. So France and Norway are going to win 186 medals. That's key. In the 2022 Winter Olympics. And we know that Norway is going to win 78 more than France. And we need to know how many medals will each country win. So we want to find the values for Norway and the values, the values for Norway and France. The number of medals for each country. Okay. So we could try to draw a picture or a diagram or a table. It's not really something that can sort of be reasonably done in this particular problem because there's really no visual that we have to gain here. So let's assign a variable. We said that if we know that one quantity is greater than or less than the other by some other quantity, then assign the variable to be that first thing, the one that the other quantity is based off of. So I know that Norway is going to win 78 more than France. So if I figure out what France is, what the number of medals for France will be, then I can just add 78 onto that and get the number of medals for Norway. So I'm going to say we're going to let x be the number of medals for France. Then I know that if I add 78 onto this number, that's going to get me the number of medals for Norway. All right, so x is the number of medals for France. X plus 78 is the number of medals for Norway. And I know that combined, or when you add them up, they are going to add up to 186. So setting up my equation here, x plus 78 is going to equal 186. Number of metals for France, number of metals for Norway, they're going to add up to 186. All right, so we've set up our equation using our variable. Now we're going to solve this thing here. We can simplify this left-hand side. I can combine these two like terms. To give me 2x plus 78 equals 186. And we can go ahead and subtract 78 from both sides so that we get the x all by itself on one side. And when we do that, that gets me 2x is equal to 108. And then to solve for x, divide both sides by 2. And that tells me that x is equal to 54. Okay, is our answer reasonable? Does this answer make sense? Well, yep, it's a positive number. You can't have a negative number of metals, and it's not possible to have 0. So this is a reasonable answer. Let's see if this answer is valid. Let's figure out what the number of metals is going to be. And we will make sure that it satisfies the problem. So we said that x was the number of metals for France. That was 54. If I add 78 onto this, I get the number of metals for Norway, and 78 plus 54 is going to be 132. So these are my answers, 54, 132. If I add those up, that does indeed give me 186, and Norway does have 78 more. So there we go. There is our solution to this word problem here. So we can see how we're going through this process and reasoning out and highlighting key pieces of information, assigning a variable to one quantity, and having a known relation to that unknown quantity that lets us solve for our variable and then solve the problem itself. Another one here, two integers, one being 4 more than 5 times the other, add up to 220. What are these two numbers? So, again, highlighting the key pieces of information. The two integers add up to 120. And I know that 1 is 4 more than 5 times the other. And I'll double underline that. So you have one number, and then the other number is, as we said, 4 more than 5 times the other. Again, drawing a picture or a diagram or a table, not as handy here. So we're going to not bother with that. This is yet another sample where we have two numbers or two quantities, and one is specified to be greater or less than the other one by some difference or sum and product. So let's assign a variable to these things, and then let's solve our equation. I know that I have one number, x. So I have x. And then I know that the other one is going to be 4 more than 5 times this guy. So 4 more than 5 times x, taking those keywords and translating it into an algebraic expression, that's going to give me 5x plus 4. 4 more than 5 times that guy there. And I know that these things add up to 220. So that is my equation here. If I take these things there is my linear equation in one variable. We can solve this now, but first let's simplify this. Like terms there can be combined. So 6x plus 4 is equal to 220. I need to get the x's by itself on one side. So to do that, subtract 4. And that gives me 6x is equal to 216. And then lastly, just get x by itself on one side. To do that, divide both sides by 6. The 6's will divide out to 1. And x is equal to 36. Once again, is this answer reasonable? I need two numbers that add up to something that's positive. So these are both positive values. If I had a negative number, when I multiplied it by 5 and then added 4, I'd still get a negative number, so that wouldn't give me something positive. So this is a reasonable answer. This is a reasonable value for x. Let's see what the other answer is, and then we'll just check that these two numbers satisfy our problem. So the integers are 36, and if I do 5 times 36 plus 4, 5 times 36 is 180, and then plus 4, that gives me 184. All right, these two numbers do indeed add up to 220. And this number is 4 more than 5 times this guy here. 184 is 4 more than 5 times 36. So that does indeed satisfy our problem, and this is our solution. So guys, this was our first video on applications of linear equations. In the next video, we are going to continue doing some more of these types of problems, but with applications to geometry and other real life situations and other areas in real life. If you have any questions or comments, be sure to reach out to me, guys. Send me an email, stop into my office, give me a phone call, whatever you have to do. Otherwise, until the next video, take it easy, guys.